What is up, everybody? My name is Anthony with Let's Get These Certs. Today's topic is comparing and contrasting the OSI and TCP IP models. This is the first video in the Cisco CCENT 100-105 video series, and upon completion we will be able to satisfy the first objective in the ICND1 exam. Now I hope you guys are as excited as I am, because as we look forward, we have a whole bunch of exam objectives ahead of us. Now, since this is our first video in this series, let's quickly take a look at all of these exam objectives and kind of get a roadmap for the future. As you can see here in this first video together, we're going to cover topic 1.1, and it is the OSI and TCP IP models. Each one of these exam objectives will be on the test, so it is super important that we do our best to try to able to identify and satisfy each one of these objectives and complete them very thoroughly. So as you can see, there's quite a bit of objectives, and it's going to be quite a bit of videos that we're going to have to cover. And at the beginning of every video going forward, we're going to review the objectives that we're going to cover through the video. So you won't normally see this big long list. It's only the first video because it's our first video together. I'm super excited. So let's go ahead and jump in with the question I'm sure you're asking yourself, and that is, what is the OSI model? And you also probably wondering why this OSI model is so important in the Cisco world, or in fact even important in the networking world. So the OSI model, well, as a definition from Wikipedia explains, it is a conceptual model that characterizes and standardizes the communication functions of a telecommunication or computing system without regards to its underlying internal structure and technology. Let's first break down this just a little bit more, and I really want you guys to focus on two key words here. And that is characterize and standardizes. Now, what this definition is telling you is that this model identifies what is going on at each layer and standardizes it across the board, and it also defines what happens at each layer, so that if you're ever working with someone, you're troubleshooting, you'll be able to talk and communicate that you're troubleshooting a layer 2 or a layer 3 issue, and the other person on the other side of the line is going to know exactly what you're talking about. So we're going to start with the OSI model first, and we're going to break down each layer. Now, there are 7 layers of the OSI model. And what's very interesting is you have to actually memorize these and know what happens at each one of these layers. And there's kind of a little trick that I learned when I was in the Navy, first starting off as an IT. And yeah, this is going to date me a little bit, but it was a sentence that I learned, which was called, all people seem to need data processing. And that starts with the first character of each word going from top to bottom. But what I learned later on in my career is not many people learned it that way. They in fact learned it the other way, starting from the bottom up. And with an even better phrase, which is, please do not throw sausage pizza away. So I since then have always used that phrase when talking about or trying to remember the OSI model. So let us start with the first layer in the OSI model and talk about what happens at that first layer. So the first layer is the physical layer, and essentially this is where the rubber meets the road, proverbial speaking, in the computer world. This is where the cable connects to the back of your computer. And it could be a coaxial cable, could be a Cat5, could be fiber, could be a gig E, could be 10 gig. Essentially, it's going to be the medium that is used where the data gets converted into a bit stream. And essentially, that data is going to be transmitted in a series of 2 numbers, and that is 1s and 0s, binary. So as we move up to the next layer, the layer 2 layer, The data link layer is very similar to the networking layer, which is going to be layer 3, except it focuses on data transfer between 2 or more devices on the same network. Now, I'm going to do a little bit of drawing here for a second, but let us assume you're in an environment where you have one computer here, you have a router here, and you have another workstation here. Now, if you don't need to get to the internet to make the communication, the devices are not even going to operate at the layer 3 level. They're going to operate at the layer 2 level. Now we have a physical device that will connect these 2 machines, and usually there's a switch in between. So each one of these devices are connected to the switch, and the communication's going back and forth. Well, it's not going to operate at the layer 1 level. It's going to operate at the next layer up, and that's at the layer 2 level. Now, switches operate at the layer 2 level, and they have, at the layer 2 level, is called MAC addresses. Well, I'm not good at writing these. So, you know what? MAC addresses. There we go. These guys operate at the layer 2 level. So this device has a MAC address. This device has a MAC address. This port will have a MAC address. This port right here will have a MAC address. Anywhere there's a connection, there's going to be a MAC address associated with that. And each one of these ports, that MAC address is going to be associated. So it's going to be like, hey, I need to go to this MAC address. Where is it at? This switch is going to say, hey, I got you, and it's going to send the packet right along the way. Now, we're going to talk a little bit more in depth on that and how and what communication is required through that. But what I want you to learn is that an example of a protocol at the layer 2 level is the ARP protocol. And if you use this command on a Windows device, it'll tell you all of the learned MAC addresses that your computer has learned. And what you'll see, which is pretty crazy, is that these MAC addresses all will be on the same network. So that communication is learned and then communicated at the layer 2 level. So if that's what happens at the layer 2 level, I'm pretty sure you're wondering what is going on at the layer 3 level. So the layer 3 level is called the network layer. And the network layer provides means of transporting variable length network packets from a source to a destination to a host in one or more networks. Now, that sounds like quite a bit, but essentially, when you try to communicate with the device that's outside of your network, let's say, and when I'm talking about outside of your network, let me get the drawing tools back up. I'm going to go with the pen. And let's assume, oops, go back up. Do it right here. Let's assume each IP address range and a class C network, and we're going to talk about the different types of networks, etc. here in a second. But if we're communicating with the device that's on, let's say, the 192.168.1 network, right? And the last octet, if any of these computers have this first 3 octets and the last octet, we are going to communicate at the layer 2 level. But what happens when you need to communicate with, let's say, Google out there? So this is when you're going to, instead of operating at the layer 2 level, you're going to operate at the layer 3 level, because this 3 and these 3 are not the same. Now, it's assuming this is a Class C network, which it's not. It's actually a Class A network. We'll get into that a little bit later on, but just bear with me. So these 2 are not the same, so we're going to have to operate at the layer 3 level. So things that are important here are ICMP ping. You've probably used that if you've ever owned a computer. Hey, I can't talk to the internet. Let me ping Google and see if Google works. If we can't talk to Google, hey, the internet doesn't work, then we back down. Hey, can we ping the router? Does the router work? Et cetera, et cetera. So another Cisco term that operates at this layer is OSPF, or Open Shortest Path First. This operates at the layer 3 level, and I'm sorry, IP address 4 and IPv6. So this is Internet Protocol version 4 and Internet Protocol version 6 all operate at the layer 3 level. So this is an example of an IPv4 address, and IPv6, we'll cover that a little bit later on, is much longer address with a whole bunch of letters and numbers that you're going to have to learn what they mean. So we'll cover that later on in the more advanced topics. So after the layer 3 network, we're going to move to the layer 4 network. Now the layer 4 network is the transport layer, and it provides the type of communication. Now there are two different types of communications, and it is going to be, whoops, keep doing this. Again, guys, this is my second video, so we're going to master this here soon. So it's going to be TCP and UDP. Now, there's actually a whole bunch of other protocols out there. For an example, DCCP, SCTP, RSVP, and a plethora of more that we're not going to talk about right now. For the exam, we're going to have to learn what TCP is and UDP and the differences between the two. So TCP is a transmission control protocol, and this is the protocol that's used when the connection is important between the communication between two devices. Now, that's important when you're sending files and like sending emails, because let's say you have a computer here and a computer here. When it sends a portion of the file, it wants to know, hey, did you receive this portion of the file? This computer will say, hey, bro, I got your file. Send me more. Then it'll send another one, and then it'll send another acknowledgement. Where you run into this, and you guys have all done it if you ever copied a file in Windows, is if you copy a large amount of files, what you'll notice is the time will start changing. It'll go from 5 minutes to 3 minutes to 2 minutes, and then 2 seconds, and then jumps all the way up to 4 hours. Well, somewhere in this communication between device 1 and device 2, it lost one of these acknowledgement packets, and it had to restart from a sequence that was much earlier. And that causes the time to be off a little bit. And that happens with a lot of communication that requires, confirmation of packets. Now, the other side of that is called the user datagram protocol, or UDP. Now, if you've ever played an online video game, which, at this time and age, even my grandma has played a video game, and my son, he plays video games as well. What they have is they'll have like this big server over here, and they're going to have all these different clients out here who are all playing the video game at the same time. And what the server is going to do is it's going to get like this packet from this guy saying, hey, I am here, right here. So then the server turns around and says, hey, everybody, this guy is out here, and sends it to everybody that's connected. But he doesn't care if the device comes back and says, oh, hey, I got that, send me the next location. And, when the character is running around, and trying to, do whatever, whether he's, shooting or doing whatever, once he moves to another location over here, he'll send out another packet saying, hey, I went from here to over here. And the server will again send out the packet. But what happens if this computer disconnects from the network, in the middle of the game? Well, the server doesn't care if the end machine doesn't receive that packet. It's just going to keep spamming out the traffic out to every workstation that's connected. So when the next device connects, it's going to be like, hey, I'm here, and then it'll send out the next packet. And essentially, this is a good example of UDP. All right. So the next layer is called the session layer. Now, the session layer of the OSI model is responsible for the session checkpointing and recovery. It allows for information of different streams, perhaps originating from different sources, to be properly combined and synchronized. Now, I always use this example, and that is, and I think I just turned it off. Okay, we have pin turned on. So let's say you are on, you're FaceTiming someone across the network, right? So one of the streams that you're going to have to send across is going to be video, right? It's going to be the picture of the person on this side and the picture of the person on this side. That video has to be transmitted across. But if this person starts speaking, hey, I'm talking over here, it also sends over audio, right? And so at the session layer, it ensures that the video and the audio match up. So when the person receives it on this side, he doesn't see the person's mouth moving and nothing coming out. He sees both the audio and the video coming out at the same time. So that's an example of communication that operates at the session layer. Now at the layer 7 is the application layer. I'm so sorry, I skipped a layer. A layer 6, I'm looking right at, is the presentation layer, and is responsible for the formatting and delivery of information to the application layer, which is the next one I was talking about, for display. Essentially, it tries to get all of the little differences and maybe some of the ASCII codes or a different kind of codes and converts it to what you want it to see at the application layer, or and it does all of this behind the work. Maybe even changes the text from here. If it changes the text from white to red or something like that, it does all of this work here before it takes the traffic and sends it on to the next layer for layer 7, where it displays a red number 7 or red common or whatever you just are doing at the layer 6 layer. Now, people don't get too much in depth to it because there's quite a bit of stuff that happens at it. Essentially, what you really want to think is like the programming languages, like null termination strings, etc. Like this is a string \0 this is a string space or something very similar to that. So for this exam, you just kind of have to have a brief understanding of what happens at this layer. So don't get too stressed out about that. And at the layer 7 as the application layer, this is when everything is all combined and made nice, and this is what you're probably looking from your screen right now is the layer 7 model, where the application essentially is in its complete form. And many examples of protocols at this layer is DHCP, DNS, FTP, HTTP. So that wraps up all of the different layers within the OSI model. And what we're going to talk about briefly is the TCP IP model. And we're not going to go through each one of these together, but essentially they like to take the summarization of the OSI model and bring it down. Instead of having 7, these guys only have, and I about made the mistake. There we go. So instead of having 7, they all have 4 layers here. Now, what happens is very similar to, please do not throw sausage pizza away. There we go. So at the network layer, essentially, it combines both the data layer and the physical layer into the network interface layer, or the network access layer. I've seen it called different things. And at the internet layer, you only associates with the network layer. And the transport layer combines the transport layer. And instead of having all 3 of these have individual ones at the OSI level, it's all combined and thrown into the application layer. So essentially, if you learn the OSI model and each one of the different layers, you essentially learn what the TCP/IP model is. I would just learn what is combined at what level. And the easiest one to remember is the first layer, or layer 1, in the TCP/IP model, the network interface or network access layer, is the first 2 layers of the OSI model. Then it's 1 for 1, and then the last 3 are all in the application layer. So I hope this covers, and I'm pretty much sure this covers every objective for our first foray into the ICND test. And going back to our exam objectives, we now know what the OSI model are, or what the OSI model is. We know all of the different layers of the OSI model, and now we also know the layers of the TCP IP models. And we can be able to easily compare and contrast the OSI and the TCP IP models because of how many models or how many layers it has. One has 7 and the other has 4. When you see one that only has 4, it is... Sorry, I lost the mouse there for a second. It is this one right here, and the OSI model is the one that has 7. So take your time. Hopefully you take pretty good notes. Go back through it and really digest and learn this OSI model, because not only for the exam but for your personal usage. There's been a lot of times that when I interview candidates for job positions at my company, one of the first questions I ask them is, give me kind of a description of the OSI model in your own words, you know? And I don't want the Wikipedia definition. But if they can't go from the OSI model and tell me why it is useful, and it's very useful for troubleshooting networks and troubleshooting communication issues, and being able to describe what happens at least on the first 4 layers of the OSI model, then that candidate, I can tell, has not had a lot of experience and or is probably not a very good troubleshooter. Because if you're not using this type of model to troubleshoot what the issue is and how to fix it, then essentially they're just saying, they'll have a user come up and they'll be like, hey, my computer doesn't work, right? And then this person's going to take a dartboard and they're going to be like, hey, you know, I think it's this issue. And not working from the ground up, trying to figure out, hey, is it plugged in? Is it this layer? Is it this layer? And this will really help you with your troubleshooting, because believe it or not, a lot of issues happen at the layer 1 level, the physical layer. And as you go up the layers, eventually you're going to find out what is causing the issue. So thank you again for taking your time to watch this video. Like I said, I'm going to work on the video content, get the audio working a little bit better, but I really just want to get this data to you guys as fast as I can. I have it here in the United States, it's going to be July 4th tomorrow, so I can get a couple of videos recorded and hopefully keep on a very aggressive schedule to get these out to you guys. Please leave any comments, concerns, recommendations for the stuff. Are the drawings helpful? Do you want me to do more of that? Less death by PowerPoint? Eventually, when we get to the practical portion of the exam, I'm going to have emulators and stuff like that to help you guys out. And we'll actually go through this, and I'll even show you how to set some of these stuff up. You know, let me know where I can improve, and so that it helps you guys out. And please, if you liked the video, please give it a big thumbs up. If you hated it and it was just utter rubbish, or I missed something, thumbs down, you know what to do. But also what would help with this channel is if you took a moment, subscribe to it, and turn the notifications on. As you see, all of these objectives above us is going to get at least all of the major objectives, like 1-3. That's going to be a fun video. 1-4 is going to be a video, etc., etc. So the more we go through this, the better I'll get, and the faster the videos will come out. So thank you again for your time, and I really hope this helps you guys out.